Now, let's go to the system with two or more particles. First, consider the system consists of two particles with mass m1 and m2 as in this figure. If the particle number 1 moves with the velocity v1 and the particle number 2 moves with the velocity v2, we define the total momentum of the system P is equal to the summation of the linear momentum of each particle. So we have that P is equal to P1 plus P2, which equal to M1 V1 plus M2 V2. Okay. Next, let's assume that the system is isolated. That is, there are only the interaction, the force from the interaction between these two particles only. There is no external force that interacts to these two particles. So, if the force on the particle 1 from the particle 2 is F21 and the force from particle 2 force on the particle 2 from the particle 1 is F12. We have from the third law that from the third law we have that F21 is equal to the minus of F12. This is the action-reaction pair. However, from the relation between force and the momentum, we have that F21 is equal to the d by dt of P1. That is, F on the particle number 1 is equal to the rate of change of the momentum of the particle number 1. And also we have that F12 is equal to the rate of change of the momentum of the particle number 2. From this relation, we have that the rate of change of the particle number 1 is equal to the minus of the rate of change of the particle number 2. Okay. Rearrange the equation. We have that dP1 by dt plus dP2 by dt is equal to the d by dt of P1 plus P2 is equal to 0. It means that the rate of change of the total momentum of the system, that is d by dt of P is equal to 0. This P is equal to the total momentum of the system, which equal to the P1 plus P2. If the rate of change of the momentum is 0, it means that the total momentum P is a constant. It means that if there is only the force from the interaction between two particles and there is no external force. The total momentum of the system, which is the summation of the momentum of each particle, will not change in time, or P is a constant. You may have that the velocity of P1 of the particle 1 and 2 may change. The particle V1 and V2 may change in time due to the force of the interaction, but when you calculate the total momentum of the system, it will not change in time. So, for the isolated system, the total momentum of the system is a constant. We can extend this concept to the system of more than two particles, and that is very easy to confirm. So, the final result is that whenever two or more particles in an isolated system interact, the total momentum of the system remains constant. So if you consider the momentum of the system at the initial time Pi and in the final time Pf, the momentum of each particle may change, but the total momentum of the system, which is the summation of the momentum of each particle, will not change in time. So we have P1i plus P2i is equal to P1f plus P2f.